Astronomers worldwide prepare to track yet another interstellar comet, anticipating nothing more than routine observations of a distant cosmic wanderer. What they discover instead shatters every established principle of celestial mechanics. 3i/Atlas defies the fundamental laws that govern cometary behavior. Unlike every comet ever observed throughout human history, it isn't casting its tail away from the sun in a familiar, predictable pattern. Instead, it's projecting a tightly focused plume directly toward our star, generating a constant thrust as though powered by some concealed propulsion system. Its chemical composition bears no resemblance to anything in our solar system. Its trajectory demonstrates uncanny precision, and its velocity of 135,000 miles per hour compels experts to fundamentally reconsider everything they thought they understood about visitors from interstellar space. If a comet can exhibit behavior that mimics artificial propulsion, something that should be physically impossible, then what exactly is 3i/Atlas? And why has its sun-facing tail left the scientific community so deeply unsettled? The Asteroid Terrestrial Impact Last Alert System, ATLAS, telescope at Rio Hurtado, Chile, identifies an anomalous moving object that matches no known celestial body in any astronomical catalog. Within moments, the automated detection system triggers alerts to its operators. The object is racing across the night sky at 61 kilometers per second, approximately 135,000 miles per hour, following a path that no object native to our solar system could possibly travel. Communication channels explode with activity as the first orbital calculations arrive. The data is unambiguous. This is no ordinary comet bound to our sun in an elliptical orbit. The trajectory is hyperbolic, with an eccentricity value far exceeding 1, an open curve that can only mean one thing. This is the unmistakable signature of an interstellar interloper, an object originating from beyond our solar system. Archive searches retrieve faint traces of the object in older Atlas and Zwicky Transit Facility images dating back to mid-June, quietly confirming its arc through space. Each additional data point refines the trajectory, inbound from the direction of Sagittarius, slicing through our solar system just 5 degrees off the ecliptic plane. The precision is breathtaking. Most comets lumber inward from the distant Oort cloud, their speeds rarely exceeding 50 kilometers per second. Yet here is an object moving faster than virtually any comet in recorded history, on a course calculated to carry it between Earth and Mars by late October. While it poses no threat to our planet, it demands immediate attention. What began as a routine discovery has transformed into a global astronomical alert. Within hours, observatories spanning 3 continents scramble to capture fresh images before sunrise claims the sky. The designation is formalized: 3i/Atlas, the third confirmed visitor from beyond our sun's gravitational domain. The clock is ticking, and every new observation frame hints at a story nobody anticipated. Hubble Space Telescope imaging specialists convene for what they expect to be a standard observing session, prepared to document another classic cometary display. Instead, the raw image frames reveal something extraordinary: a luminous plume arcing directly toward the sun. A sunward jet, narrow and persistent, dominates the view. The standard anti-solar tail, the one that should point away from the sun, appears faint, almost negligible. Independent observations from Gemini South Observatory confirm the bizarre orientation. Analysts systematically check for instrumental artifacts, recalibrate optical filters, and cross-reference with the Gaia star catalog to eliminate any possibility of background contamination. The plume remains consistent across multiple exposures, its structure unchanged despite varying viewing angles and fluctuating solar wind conditions. Astrometry teams, utilizing Hubble and Gemini's high-precision tracking capabilities, meticulously map the object's motion against background reference stars. The measurements refuse to conform to familiar gravitational patterns. Each positional update reveals a subtle yet unmistakable deviation from a purely ballistic trajectory, an additional acceleration measuring approximately 4 times 10 meters per second squared. The acceleration vector aligns precisely with the sunward plume. This is no random outgassing event, no tumbling jet firing in arbitrary directions. The force is directional, continuous, and invariably aligned with the visible jet structure. Standard radiation pressure models fail to explain the phenomenon. For micron-scale dust particles, solar radiation pressure should sweep the plume away from the sun, not toward it. Maintaining such a jet would require either significantly larger, heavier grains or something entirely unprecedented in cometary science. The result, an object that appears to propel itself sunward, as if driven by an invisible engine. For the imaging and astrometry teams, the data raises a question that current physics cannot answer. What mechanism could possibly create a comet tail that functions as a propulsion system? Jet simulation experts at the University of Maryland run comprehensive calculations on the sunward plume. To reproduce the measured acceleration of 4 times 10 meters per second squared, the object would need to expel mass at a rate exceeding 300,000 kilograms per second. That's the thrust output of a small rocket engine, not a passive comet. Yet actual dust and gas loss rates, measured through careful photometry and spectral mapping, register between 0.1 and 1 kilogram per second. The discrepancy is staggering. Even if every visible grain in the plume were ejected at maximum possible velocity, the observed material falls short by a factor of at least 10,000. No comet anywhere in our solar system exhibits such an extreme mismatch between observed mass loss and measured acceleration. JWST's spectroscopy team, led by Dr. Carrie Leese, performs a detailed analysis of the comet's coma, the cloud of gas and dust surrounding its nucleus. The spectral data reveals carbon dioxide dominating water ice by a ratio of 8:1, a complete inversion of the typical cometary composition. Even more puzzling, distinct atomic nickel emission lines appear prominently in the data, while iron is conspicuously absent. On Earth, nickel and iron are virtually inseparable companions, found together in meteorites and manufactured alloys throughout both natural and industrial processes. In 3 Ice/Atlas, nickel stand alone. The team conducts exhaustive checks for calibration errors and cross-matches results with laboratory reference spectra. The signal persists unchanged. Every conventional model, whether invoking sublimation physics, gas drag mechanics, or ballistic ejection, fails to bridge the enormous momentum gap. The aberrant chemistry only deepens the mystery. If the measurements are accurate, something is actively pushing 3 Ice/Atlas toward the sun with a force that nature has never before demonstrated. Orbital dynamics specialists at Harvard incorporate the refined trajectory data into sophisticated Monte Carlo simulation models, running millions of randomized interstellar arrival scenarios. The statistical probability that a random object would approach our solar system just 5 degrees off the ecliptic plane, threading past Mars, Venus, and Jupiter in sequence, calculates to less than 1%. Most interstellar visitors should arrive at steep angles, passing high above or far below the planetary disk. Yet 3 Ice/Atlas's path aligns with every major planet except Earth in an almost choreographed sequence. Analysts who scrutinized the 2017 Oumuamua anomaly returned to the conversation, noting that Oumuamua's trajectory also hugged the ecliptic plane unusually closely, though without the dramatic series of planetary encounters. That earlier visitor exhibited puzzling acceleration as well, but never revealed any tail or plume, just a silent, tumbling shard hurtling through space. In stark contrast, 3 Ice/Atlas broadcasts its presence with a visible, highly structured jet and follows a trajectory that feels almost deliberately calculated. SETI-focused theorists and planetary dynamicists engage in heated debates through preprint publications and late-night live streams. Some characterize the chain of planetary flybys as an extraordinary cosmic coincidence, a statistical outlier in an infinite universe of random events. Others openly question whether the path itself might constitute part of a signal, an engineered demonstration, or perhaps a test to determine whether anyone is observing carefully enough to recognize the anomaly. The approaching solar conjunction blackout window adds mounting urgency to every new calculation. If the trajectory undergoes significant changes after 3 Ice/Atlas emerges from behind the sun, it will represent the first genuine test of intent versus chance. Until that moment arrives, the object's statistically improbable path stands as both an enigma and a challenge. Is this merely an unlikely coincidence? Or is someone or something deliberately navigating through our solar system with clear purpose? As 3 Ice/Atlas sweeps behind the sun, Every telescope on Earth in orbit confronts an unavoidable observational blackout. For several weeks, the object will be completely lost in overwhelming solar glare, invisible even to our most sensitive instruments. NASA's mission schedulers and ground-based observatory teams coordinate their final observing campaigns, racing to capture the last possible measurements before conjunction. Contingency plans circulate through the astronomical community, but everyone understands a fundamental limitation. No amount of funding or technical ingenuity can bridge this observational gap. The data stream will halt entirely, leaving a frustrating blind spot at the precise moment when the object reaches perihelion, its closest approach to the Sun. For tracking coordinators, the risk is crystal clear. Any change of velocity or direction during this window will go completely undetected. The world holds its collective breath, waiting for 3i/Atlas to re-emerge on the far side of the Sun. With the world's telescopes temporarily silenced, speculation intensifies across scientific and public forums. SETI theorists debate whether 3i/Atlas fits the conceptual framework of a Bracewell probe, an autonomous sentinel designed to await signs of intelligent life. Others interpret the carbon dioxide-rich, nickel-laden plume as evidence of intentional dispersal, perhaps a terraforming payload being distributed across multiple planetary targets. Some frame the object as an interstellar intelligence test, its physics-defying tail and clockwork-precise trajectory deliberately set up as a challenge. Will anyone notice that the fundamental rules are being systematically broken? The darkest hypotheses invoke the concept of dark forest debris, wreckage from an ancient cosmic conflict, drifting through space with damaged propulsion systems still sporadically firing. Yet across all camps, one point of consensus emerges. The only decisive test arrives after the blackout period. If 3i/Atlas reappears in December 2025 with a trajectory that veers beyond predictions of gravitational models and known physics, the debate will enter an entirely new phase. Until that moment, every model, every theory, every speculation hangs in suspense. Detailed computational modeling has confirmed that the observed mass loss is at least 10 times too low to explain the measured acceleration effect. JWST spectroscopic analysis has revealed the unprecedented carbon dioxide to water ratio of 8:1, along with the presence of nickel in complete absence of iron, a chemical signature found nowhere else in nature. If the post-conjunction trajectory shifts beyond what solar gravity alone can account for, the debate over natural versus artificial origin will transcend academic discussion and enter new territory entirely. For now, 3i/Atlas stands as the most perplexing interstellar visitor ever recorded in human history, fundamentally challenging our understanding of cosmic phenomena and the boundaries between natural celestial mechanics and something potentially far more extraordinary. The world waits for December, when the object will either confirm itself as an extreme but natural phenomenon, or reveal itself as something that compels us to reconsider our place in a universe that may be far less empty than we believed. The first detection comes from the European Southern Observatory's Very Large Telescope in Chile. A technician monitoring the automated tracking system notices the familiar spectral signature emerging from the solar glare. Within minutes, confirmation cascades through the global network. 3i/Atlas has survived perihelion. But something has changed. Dr. Maria Chun at the Jet Propulsion Laboratory pulls up the preliminary orbital data, her hands trembling slightly as she compares it to the pre-conjunction predictions. The trajectory has shifted, not by the minuscule amount that solar radiation pressure might explain, but by a full 0.8 degrees. For an object at this distance and velocity, that represents a course correction requiring sustained thrust far beyond anything natural physics can provide. It turned, she whispers into the emergency conference call, her voice barely audible. It actually turned. The acceleration vector has rotated as well. The sunward plume, so prominent before conjunction, has diminished to a faint wisp. In its place, a new jet has emerged, this one firing perpendicular to the sun, applying thrust in a direction that will bend 3i/Atlas's path toward the outer solar system, rather than slinging it back into interstellar space. SETI's Allen Telescope Array picks up the anomaly first, a narrowband radio emission at 1.42 gigahertz, the hydrogen line, the frequency that every astronomer in the galaxy would recognize as artificial. The The signal pulses in a mathematical sequence, prime numbers, then the Fibonacci sequence, then something more complex, a three-dimensional coordinate system that takes Dr. James Okonkwo at Berkeley 3 sleepless nights to decode. The coordinates point to a location in the Kuiper Belt beyond Neptune's orbit, a rendezvous point. It's not just intelligent. Dr. Okonkwo announces in a hastily arranged press conference, his exhausted face projected on screens worldwide. It's trying to communicate. And I think it's inviting us somewhere. The scientific community fractures into camps overnight. Some call for immediate mission planning, humanity's first interstellar contact opportunity. Others urge extreme caution, invoking every cautionary tale from science fiction about answering cosmic invitations. The United Nations convenes an emergency session. Religious leaders offer conflicting interpretations. Social media explodes with theories ranging from salvation to invasion. Hubble captures the moment that changes everything. As 3I/Atlas crosses Mars's orbit outbound, the object begins to unfold. What astronomers had assumed was a single nucleus separates into 7 distinct components, each moving with perfect synchronization. The fragments arrange themselves in a geometric pattern, a three-dimensional hexagonal array with one component at the center. The sunward plume reignites, but now all 7 pieces fire in coordinated pulses, like the attitude thrusters on a spacecraft making fine adjustments. The spectroscopic signature shifts dramatically. The carbon dioxide plume dissipates, replaced by emissions that match no known chemical process. Xenon, argon, and krypton, noble gases that should never appear together in these ratios, dominate the new spectrum. Dr. Lee's team recognizes the pattern immediately. It's the exhaust signature of an ion drive, the same propulsion technology humanity has only recently begun deploying on our most advanced spacecraft. This was never a comet, Dr. Lee states flatly during the follow-up briefing. The icy nucleus, the outgassing, it was camouflage. Or maybe it was collecting reaction mass from solar wind and our sun's corona during perihelion. Either way, we're looking at a functioning spacecraft, and it's been studying us. The decoded message from 3I/Atlas contains more than just coordinates. Dr. Okonkwo's team unravels additional layers buried in the mathematical sequences, diagrams showing orbital mechanics, propulsion physics far beyond human capability, and a timeline. The rendezvous window will remain open for 18 months. After that, 3I/Atlas will accelerate beyond reach, departing our solar system at speeds that will carry it to the nearest star in less than 4 centuries. The message includes one more element that sends chills through every analyst who sees it: a schematic of Earth with remarkable detail, our continents, our oceans, and 7 glowing points marked across the planet's surface. Major cities, population centers. The probe has been watching, learning, cataloging. But the message carries no threat, no demand, just an invitation and a deadline. NASA Administrator Dr. Rebecca Torres faces the cameras on December 20th, flanked by representatives from ESA, JAXA, and Roscosmos. "We are announcing a joint international mission," she declares, her voice steady despite the magnitude of what she's proposing. Project Envoy will launch within 8 months. We're going to that rendezvous point. We're going to meet 3I/Atlas. And we're going to find out who sent it and why. She pauses, looking directly into the cameras. For the first time in human history, we're not alone. Someone out there, has reached out across the vast darkness between stars to make contact. Whatever happens next, whatever we discover, humanity will face it together. The spacecraft sits on the pad at Kennedy Space Center, a joint construction of 12 nations, built in record time using every advance in propulsion technology humanity has achieved. Envoy is a gamble. Carrying a crew of 6 astronauts representing 6 continents, equipped with communication systems, scientific instruments, and a digital library containing humanity's accumulated knowledge, art, music, and messages from millions of people worldwide. As the countdown reaches 0 and Envoy's engines ignite, lighting up the Florida sky, 3I/Atlas crosses Neptune's orbit, its 7 components still moving in perfect formation. The probe adjusts its trajectory one final time, settling into a precise orbital pattern around a previously unknown Kuiper Belt object, a tiny, dark worldlet that suddenly becomes humanity's most important destination. The signal from 3I/Atlas pulses one last time before falling silent. The same prime number sequence, followed by a new addition, a simple binary message that translates to a single word in every language on Earth. Welcome. As Envoy begins its 3-year journey into the outer solar system, humanity stands at a precipice. 3I/Atlas has transformed from an astronomical curiosity into proof of a cosmos teeming with intelligence, technology, and intention. The probe's builders, whatever they are, possess capabilities that dwarf our own, yet they chose invitation over invasion, communication over conquest. But questions linger in the minds of everyone who studies the data. Why now? Why us? And perhaps most unsettling, if 3I/Atlas is the third interstellar object we detected, how many others pass through our solar system unnoticed, undetected, silently observing? The scientists who first tracked that anomalous speck in July 2025 could never have imagined where their discovery would lead. What began as a violation of cometary physics has become humanity's first confirmed contact with intelligence beyond Earth, a contact that promises to reveal either our greatest hopes or our deepest fears about the universe we inhabit. In living rooms and laboratories, temples and observatories across the globe, people look up at the night sky with new awareness. Somewhere out there, beyond the reaches of our sun's light, other minds are thinking, building, reaching across the impossible distances of space. And they know we're here. The story of 3I/Atlas is far from over. In fact, for humanity, it's only just beginning. Commander Sarah Okafor floats in Envoy's observation deck, watching the distant points of light that represent 3I/Atlas's 7 components. After 2.5 years of journey, countless system checks, and enough recycled air to make her never take a fresh breeze for granted, they're finally within visual range. 30 million kilometers and closing, announces Lieutenant Kenji Tanaka from the navigation station. At current deceleration, we'll reach the rendezvous sphere in 72 hours. The crew has changed during the journey. Dr. Amara Osei, their astrobiologist, has filled 17 notebooks with theories about what they might encounter. Dr. Yuri Volkov has grown a beard that would make any Russian cosmonaut proud. Chun Wei has become the ship's de facto philosopher, spending hours of meditation, preparing his mind for whatever revelation awaits. Dr. Isabella Reyes checks and rechecks her communication arrays obsessively. Kenji maintains his calm precision, while Sarah carries away to command, knowing that her decisions in the coming days might determine humanity's future among the stars. The probe has remained silent since that final welcome message. No new signals, no course corrections. Just 7 geometric points of light, maintaining their perfect hexagonal dance around the Kuiper Belt object designated KB 2025 X47. Commander, Isabella's voice cuts through the silence. Tension evident. I'm picking up something. Not from 3I/Atlas, from the object it's orbiting. X47 is transmitting. As Envoy matches orbit with KB 2025 X47, the crew's instruments reveal what should be impossible. The Kuiper Belt object isn't a natural worldlet at all. Beneath a thin veneer of ancient ice and rock lies a structure, vast, geometric, and undeniably artificial. It's a station, Yuri breathes, his fingers flying across his console. Diameter approximately 800 meters. The ice shell is camouflage, probably accumulated over millions of years. But underneath, my God, the architecture is pristine. The 7 components of 3I/Atlas maneuver with fluid grace, taking up positions around the structure like honor guards flanking a temple. A section of the ice shell splits open with no visible mechanism, revealing a docking aperture that gleams with the unmistakable sheen of manufactured alloy. Sarah makes a decision that she's been simultaneously dreading and anticipating for 3 years. Prepare the shuttle. We're going in. The interior defies every expectation. Vast chambers stretch in directions that seem to bend geometry itself. Architecture that suggests the builders understood physics at a level humanity can barely theorize. But it's not empty. The corridors are lined with what can only be described as storage vessels. crystalline containers holding objects, samples, data cores made from materials that shimmer with inner light. It's a library, Amara whispers, her voice echoing through their comm system. A repository. This isn't just a probe. 3I/Atlas was the messenger. This is the message. Dr. Reyes interfaces her equipment with one of the data cores, following instincts that seem to transcend language. The crystalline surface responds to her touch, projecting holographic displays that shift and morph until they settle on a format the human mind can process. Images, mathematical diagrams, star charts. What they show stops every crew member in their tracks. The data cores contain the recorded knowledge of civilization that called itself the Architects, a species that reached the stars 3 million years before humans learned control fire. The archive reveals their history in layers. Their rise from a water world orbiting a star the humans will later identify as Kepler 442, their development of faster-than-light communication, though not travel, their expansion to the galaxy not through colonization, but through understanding. The architect had made a discovery that shaped their entire philosophy. Intelligence was rare, staggeringly rare, but not unique. They had found evidence of 17 previous civilizations scattered across the galaxy, all extinct, all having destroyed themselves within 10,000 years of achieving technological sophistication. War, environmental collapse, artificial intelligence singularities, resource depletion. The causes varied, but the outcome was always the same. Extinction. They called it the silence threshold. Chinwei reads from the translated data, his face pale. Every species reaches a point where their technology outpaces their wisdom. Most don't survive. The galaxy is littered with the ruins of brilliant civilizations that learned too late how to coexist with their own power. The architect's response to this revelation was audacious. They would seed the galaxy with libraries, hidden repositories placed in stable orbits around promising star systems. Each library would remain dormant, camouflaged, monitoring, waiting for a species to demonstrate the key criteria: the ability to detect an anomaly, the curiosity to investigate, the technological capability to reach beyond their home planet, and, most critically, the wisdom to cooperate rather than compete. 3I/Atlas wasn't just a probe, Sarah realizes, the implications cascading through her mind. It was a test. Every behavior exhibited, every impossible maneuver. It was designed to make us pay attention, work together, push our capabilities. And by coming here as a unified mission instead of a national competition, we pass. Kenji finishes quietly. Deeper in the archive, they discover the architect's fate. No invasion, no cosmic catastrophe, just a slow decline into stagnation. Having spread their knowledge across the galaxy, having seeded their libraries on 10,000 worlds, they had lost their sense of purpose. Their last transmission, dated approximately 800,000 years ago by human calendar, was a final message to whoever might find their archives. We preserve knowledge because creation without preservation is merely noise. We search for others because existence without witnesses is merely solitude. If you are reading this, you have proven yourselves worthy of survival. What you do with that worthiness will determine whether the universe remembers your name or your silence. The archive contains more than history and philosophy. It holds practical knowledge, energy generation methods that humanity won't theorize for centuries, medical treatments for diseases still considered incurable, atmospheric restoration techniques, and most tantalizingly, the mathematics required to manipulate gravity itself, the first step toward true interstellar travel. But there's also a warning, rendered in such clarity that its importance cannot be missed. Knowledge without ethical foundation leads only to accelerated collapse. The archive contains a test protocol, a series of challenges that must be solved demonstrating not just technical capability, but moral reasoning, cooperation, and long-term thinking. They're not just giving us the keys to the universe, Amara says slowly. They're making sure we're mature enough to use them. The crew spends 3 weeks in the library, cataloging what they can, understanding a fraction of what they encounter. The 3I/Atlas components remain in their positions, still transmitting their navigational beacon, still silently observing. On the final day before Envoy must begin its return journey, Sarah receives a priority transmission from Earth. The video shows a packed United Nations assembly, representatives from every nation. Their face is a mixture of hope and fear. Secretary General Mwansa speaks directly to the camera. Commander Okafor, the world is watching. What you've discovered represents humanity's greatest opportunity, or greatest danger. The question before us is simple. Are we ready? Should we accept this gift? Sarah looks at her crew. These 5 people will become more than colleagues. They are witnesses to a pivotal moment in human history. Each face reflects the same internal struggle. The intoxicating promise of advancement versus the sobering reminder of what happens to species who grow too fast. She thinks of the 17 extinct civilizations, of the architect's own fade into oblivion, of every warning embedded in the archive. But she also thinks of humanity's potential, of the problems its knowledge could solve, of the diseases it could cure, of the environmental collapse it could prevent. Mr. Secretary General, she finally responds, her voice steady. I believe we should accept, but not immediately and not without conditions. The archive contains an educational protocol, a curriculum designed to prepare a species for advanced knowledge. It will take generations to complete. But if we commit to it, if we prove we can master not just the technology, but the wisdom that must accompany it, then yes, we're being offered a chance to join something greater than ourselves. We should take it. She pauses, looking out at the impossible structure that has waited so patiently for humanity to arrive. But we have to earn it first. The architects understood something crucial. Any species capable of reaching the stars must first prove they won't use that capability to destroy themselves or others. That's the real test. Everything else is just prologue. As Envoy begins its long journey back to Earth, 3I/Atlas makes one final maneuver. The 7 components synchronize their ion drives, breaking orbit from the library structure. They don't accelerate outward toward interstellar space, as mission control expected. Instead, they enter a slow spiral inward, beginning a multi-year journey toward the inner solar system. Dr. Reyes picks up one last transmission, brief and enigmatic. First contact complete. Transition to Phase 2, observation and assessment. Duration, 1 human generation. Prove yourselves worthy, young ones. The galaxy is vast, and you are no longer alone in it. The probe settles into a parking orbit at the Lagrange point between Earth and the Sun, close enough to watch, far enough to remain unthreatening. A reminder, a guardian, a judge. Dr. Kenji Tanaka, now director of the International Archive Studies Program, stand before a classroom of students who were born after first contact. They've never known a world without the knowledge that intelligent life exists beyond Earth. To them, the library is simply a fact of existence, like the moon or the stars. The architects left us a choice, he tells them, his hair now silver, his face lined with years of profound study. They gave us access to knowledge that could vault us forward centuries or destroy us if we misuse it. For 25 years, we've been following their educational protocol, learning not just their technology, but their philosophy, understanding not just how to manipulate gravity, but why we should consider the consequences before we do. One student raises her hand. Professor, when will we complete the protocol? When can we start using the advanced technology? Kenji smiles, the same patient smile Sarah had given him decades ago aboard Envoy. That's the question every generation asks. The answer is, when we stop asking, when can we use it, and start asking, are we ready to be responsible for it? The protocol has no fixed endpoint because wisdom isn't a destination, it's a practice. He pulls up an image on the screen. 3I/Atlas, still maintaining its vigil at the Lagrange point, its 7 components glinting in the sunlight. They're still watching, waiting to see what we become. And, you know what? So am I. Outside the classroom window, a new generation of spacecraft launches toward the library, carrying scholars, scientists, philosophers, and artists, each person chosen not just for their brilliance, but for their character, each committed to the long, patient work of proving humanity's worthiness. The probe that broke every rule of celestial mechanics had delivered a message more profound than any radio signal. The universe is full of possibilities, but survival requires more than technology. It requires wisdom, patience, the willingness to grow slowly rather than burn brightly and fade. Humanity has been given a chance. Whether they seize it or squander will be written in the stars, or in the silence that follows.